Hey kids, Flexing Teacher Weber here. I hope you're having a good night. I'm going to do a review of all the notes and examples we've done on equivalent fractions. So that'll help you with some of the work we're going to be doing over the next little while, because you'll need to know these things really well to do all sorts of things with fractions. So what we started off with is the definition of equivalent fractions, fractions that share the same relationship between part and whole. So what that basically means is that an equivalent fraction, two equivalent fractions are the same, but they're cut into different parts. So if you look at this example right here, the yellow part is the fraction that is 1/3 on this first circle. So this part in here that was colored yellow that I'm currently shading in black, that part is 1/3. And on the other circle, that exact same size section on this circle is cut into 6 parts, so this is 2/6. So it's the exact same size piece, but just cut into different parts. That's the definition of an equivalent fraction. So that's when you're talking about parts of a whole, but it works the same when you have parts of a group. So on this one right here, we have the fraction 3/4 if we're talking about the amount of red counters out of the total. And if I want to make equivalent fractions out of that, I can keep making that same size fraction, but I'll just get more parts. So this one right here that I'm making is 6/8. So what I have so far is I have 3/4, and then I also have 6/8. And what you can see is that to make an equivalent fraction with just the numbers, all I need to do is multiply the numerator and denominator by the same number. And so that works. If I want to keep going, I'll make another equivalent fraction. So I'll do the same thing, 3/4. My diagrams aren't great, but they do the job. So now we have the fraction 12 equal parts, or 12 parts of the group, and 9 of them are red. And we could go on and on and on like that. And if we go to the original fraction to get the one that's 9/12, I would simply multiply the numerator and denominator by 3, and I'd get the 9/12. So that's how equivalent fractions look as pictures. And if we look at another one here, I have the fraction 3/5, but I can also make the fraction 6/10, right? By making groups that are all 3/5, right? So now this equals 6/10. Okay, and we can get that by multiplying the denominator and the numerator by the same number. And I could go on and on and on like that. So that's how we started out. And then we moved into doing this just with numbers. So we use this idea of equivalent fractions to do all sorts of things. So to determine if fractions are equivalent, write them in lowest terms. So building on our previous knowledge, we can figure out if fractions are the same by writing them in lowest terms. So take a look at these examples here. We have 8/12, and we have 14/18. And to figure out if they're the same fraction or equivalent, we'll put them in lowest terms. For the first fraction, I can divide 8 by 4, and I can divide 12 by 4. And I get that that's 2/3 in lowest terms. Now for the second fraction, I can chop both in half by dividing by 2, and I get 7/9 in lowest terms. Now we can see here that when in lowest terms, both fractions are not the same. So we would say they are not equivalent. And then we'll take a look at another example. 5 over 25 and 4 over 20. And to get them in lowest terms, the top one, I divide the numerator and denominator by 5, and I get 1/5. And the bottom one, I divide the numerator and denominator by 4, and I get 1/5. So both fractions are now in lowest terms, and we can see when in lowest terms they are exactly the same, so we say they are equivalent. So that's some uses of equivalent fractions to figure out if fractions are the same. What we'll do in the next video, I'll leave that one here. What we'll do in the next video is we'll look at some ways we use equivalent fractions to find missing numbers in some number puzzles. So that should help you with some of the stuff on equivalent fractions, give you an idea what they are. But the second video will go into a little more in-depth in equivalent fractions. That's all for now. Wait for the next video. Trust me, I'm flexing. Flexing Teacher Weber out.